Welcome back, everyone, to the second part, class number 6, number 2. This is where we ended up on the first class here, machining everything on the main spindle. We'll just go through that real quick here. So this is what we did on the main spindle. Now what we want to do, of course, we're going to bring in some chuck jaws and transfer this to the sub-spindle. So the first thing we want to do here is go to File and Import. And this is going to be a chuck with the jaws. And that will be available to download as well. So anytime you bring in a solid model, of course, Gibbs turns it into a part file. So if you go to the rendering, you'll see it doesn't show up. So let's click on this. I'll make sure face selection is off. Click on the whole chuck and jaws. Right click. Go to body type, change it to fixture display only. We don't want it to do fixture. It'll give us a different toolpath, or not necessarily, but it will avoid hitting the fixture if you have this, but it takes a little longer to process the file. So we know everything's going to clear, so I'm just going to click on fixture display only. And you'll see it turns red unless you, of course, change the colors. Now if we went to OpSim and click on play, you'll see it's going to rotate the chuck just like it would in the real world. There's our first rough, or second, third and fourth, and then deburr. So now we want to bring it over to the sub-spindle. So let's turn off rendering, let's turn off cam, just go to front view there. Before we do that, let's go to document control first, and let's put in our graphic part face distance. I'm going to choose 12 inches there. That's just a visual, of course. That's not where your actual machine is, but it keeps the spindles close together on your screen. And then let's go to part stations and make sure we turn on the sub, so you can see it's turned on now. Now we want to transfer pretty much everything over from the main spindle to the sub-spindle. Let's first go to our document control first. This will make it a little bit easier for you. Go down to sub-spindle, and let's just zero every one of these out. This will make it easier for transfer. Let's go back to main spindle here, and let's look at our clearance, 2.6 and 0.25. So we're going to use the same thing here on the sub-spindle. It doesn't have initial stock on there. If we were going to do mass productions, real high mass productions, I'd probably have initial stock in here and have both a blank piece over here when we start the spindle and a half finished part over here. But we're just going to transfer it normally from the main spindle to the sub-spindle. So let's go to our coordinate systems, make sure we're on the ZX plane here, and go to our work groups and go to turning. So we want to capture, of course, the solid model itself and the geometry for turning, because we need to do turning on the back side there. So I'm going to click on that as well, hold the control down, and then we're going to, let's turn on dimensions here so I can get some dimensions here. So our overall part is 0.790, and then we have, of course, half-inch stock there. So our overall length would be 0.790 plus 0.513. I guess I could dimension that. That would be make it probably a little bit easier there. So let's undo that. Let's do some dimensions here while we're at it. Okay, so I'm going to click on the front part because this is all done now. And the back part right there. And I can see that's exactly, let me move that up out of the way, exactly 1 inch. Okay. So now I can click on our part, double click the geometry, go to modify, duplicate, and translate. And we want it to go, remember our part distance is 12 inches here, theoretical part distance. So I'm going to do 12 plus 1, of course, 13, just one time. And there, it's going to transfer it over to the sub. I don't know why I have this other old geometry. Let's just get rid of it. Okay, now we want to tell Gibbs that this part is actually in the sub-spindle. All Gibbs knows is we took this part and we transferred it or translated it over 12 inches. It doesn't know that it's in the sub-spindle. Let's turn off this. So we need to tell Gibbs that everything over here should be related to the subspindle. So first of all, let's go to our coordinate system. Open that box there. And we want to highlight everything on this side, but before we do that, click on the part and you'll notice they're still attached together. Now we don't want that to be that way because if we happen to move this, it's going to move this one as well. So we want to separate those. So we just go to Solve Modeling, click on this button here that says Separate. Now you'll notice they're individual pieces. Okay. But also the geometry, notice it's blue. That says basically it still thinks it's from the main spindle. So we want to make sure the blue as well as the solid is associated with the subspindle. Easiest way to do that, hold Shift key down, just select all this, go to the ZX plane subspindle, right click, and tell Gibbs you want to change the CX to this current coordinate system. Now you'll see this is blue because we're in that coordinate system. This is purple. If I went back to the ZX plane on the main spindle, you'll see that's blue. This is purple. So now Gibbs knows everything over here is associated with the subspindle. Let's do a little check on the dimensions to make sure we got it right. Let's turn on our coordinate system there. Again, one more time. Let's go to the coordinate system ZX plane, subspindle. Let's just check to make sure we put it right. If we need to move it, we can. It's real easy to do. So just right click anywhere on the geometry, go to mouse position. Let's click on the front of this part right here. And we can see I'm 0.85 off. Must have not put a number in correctly, so that's okay to do. Don't worry about it. So let's just select it all. Go to Modify and let's just translate it to minus 0.085. Click Do It. Whoops, went the wrong direction, sorry. Should be positive because the positive's pointing that way on the subspindle. All right, now let's bring up our mouse position here. Click on the front of that, and that should say 0, which it does. You can see over here it says 0. We can also dimension that if we'd like here. Got my dimension palette here. Click on this here. We're on the subspindle, and you can see that's Z0. So everything's good here. Now I can fill out the blanks for the rest of the part. Let's probably get our chuck over on the sub side as well. So I'm just going to click on this chuck, and we'll just go back to the coordinate system. And you can do it a number of different ways, but I'm just going to go to the regular coordinate system, and I'm going to go mirror that, duplicate and mirror. I want to duplicate it. I'm going to go, we could calculate it out, but I'm going to say approximately 15, no, we'll say 10 inches because the mirror point out here. Okay, so now we mirrored it over here. So what we can do is just move it up here, but we'll wait a second until we get some dimensions on there first. So the first thing I want to do is get my chuck over here to this side. Now, since we duplicated it and mirrored it, we want to make sure we separate that as well. So make sure you separate that so they're individual. Let's also call this the subspindle part. So make sure you click on ZX plane. It's already highlighted, so just click on Change CS, X, Y, Z. So now it knows it's in the subspindle. So let's pull a little dimension off this so we know how far to translate it over there. I'm just going to turn on edge selection and just select one of the edges there and extract the edges just so we have a point there. I'll delete that just so we ended up with a point. We'll just do a single point. So there's one single point left on there. That's all we care about. And if I dimension that, you can see it's 8.750 from origin. Now I want to have the subspindle come and grab it right there, right before that radius. So I'm going to dimension that one as well. So now all we need to do is select our subspindle, select the point as well so you can make sure the dimension's right. go to modify and translate. We want to go positive because that's pointing positive. So we want to go 8.750, which would bring it to the beginning, and we want to go minus 0.303. And that should put it exactly where we want it, right on that corner, or before the radius. Let's turn off dimensions there. Okay, so now we have our subspindle in place for when we do the grab and when we do the subspindle return. So let's turn on our dimensions. Let's go to document control. Now let's fill out the rest of this page on the subspindle. Let's go to subspindle. We already did our X diameter and Z clearance for the sub, so that's good. So basically right here, this is how much you need to face off the subspindle. So if we zoom up this a little bit just to see the dimensions here, you can see we have, there's the front of our part on the subspindle, and this is how much material we had in the chuck on the main spindle, 210. So we need to face off 210. Now this right here is how much material is in the subspindle. So remember, we faced all this off here. We could dimension this if we'd like, but let's go to the subspindle. You can see this is purple. An easy way to change that over, just right click and change to the coordinate system it's in. Now these two dimensions down here is how much material we're actually holding inside the jaws on the subspindle and how much is actually sticking out. So let's just dimension some of this. You can see we have 0.487 from where we are holding inside the jaws there. So 0.487. Now this is how much is sticking out of the jaws from where we grabbed it. So from right here to here plus our stock. So I don't have a dimension here. I don't have a point to dimension that, but let's just look over here. So I'm grabbing right here, and this is how much stock we have total. So if I look at this, I can see from here, I already have the dimension 0.513 out to our stock. So this should be 0.513. Okay. Let's turn off our dimensions here. Close everything out. And as you can see, when we render, you're not going to see anything happening on the subspindle yet because we haven't got to that point yet. We'll just speed through that pretty quick. Okay, so we're at the end of the program with the main spindle. So let's turn off our cam, turn on our tools, clear everything out here. So the first thing I want to do, I want to get the turret out of the way before the subspindle comes forward. Of course, even if your tools are in the correct place, this chuck should clear everything, but I always like to get it over here close, as far out of the way as possible before the subspindle comes forward. So here we just do a utility. And I'm going to use tool number 1 that's on the main spindle. Because where I'm telling it to go, I want it to go right here, because I don't want it to go past here. I could, but I'm just guessing. I don't want to run into anything over here. So I know at Z0 over here, everything clears, the sheet metal and everything else. So let's do the move tool group. So I'm going to leave the X home, Y home, but the user, I'm going to put it, or since we're not parting it off, I'm just going to leave that at 0. And I want it to do it by the part. You can see I have part station receptor, none of that. Part station would be kind of the center of the spindle. Let's just do part. So it's looking at the tool. And I want to do it by the tool tip, not tool group datum. So make sure that's correct. And of course we need a tool in there. Yes, we chose a tool, so let's just click do it. Okay, so now what this did is move the turret over here out of the way. So the next utility we want to do, since we already have this open, we'll use this. Let's just go to subspindle in. Okay, main spindle to subspindle, subspindle on. I usually always have it turning because that turns the air blow on to blow all the chips off the subspindle. Forward, 500 RPM is pretty good for what I like. And we need to sync the spindles because we have timing on the back side that we have to deburr the holes, or this flange, as well as the holes and the deburr inside here. So we want to make sure that's synced. So the Z clearance, this means how close do you want the subspindle basically to rapid. Not quite rapid, but pretty close. How far you want it to go before it starts feeding on. And usually when I start out, I usually use 20. The default I think is 200. That's pretty fast. So when you're testing this out, that's a little fast. So for my first part, I'll go 20, and then I'll just change this in the program to 200. So ½ inch away, 20 it. Now where do I want to grab? Now you want to make sure you're on the ZX plane main spindle. I'm going to zoom this up here. I'm going to highlight this box here. Hold the Alt key, click on that point right there, and you can see that's minus 0.487. And everything else looks good. Don't need to do any shift angles, so click on Do It. So now the subspindle has come over and grabbed the part. Now we need to do subspindle return. Main spindle to subspindle, subspindle on 500, feed rate 200. That'll almost go rapid back home, but not quite, with the part. And you always want to make sure you click Open Main Collet. Since you're not parting this off, we want to have the subspindle grab it, and then there's a dwell there, so this has time to grab it, and then the main spindle will open up, and then we move back home. You could do a detection RPM if you want, but you don't have to. And Open Main Collet, so click on Do It. So now we want the turret to go back to its basically home position, which is right in the middle of the two spindles here, because we're using a G30 and not a G28. So let's just close this. Let's bring back our move tool group we already did, and just change this to no move or machine home. Depending on your post, you can have it probably do either one, but machine home for here will be the center. The tool number one in this case will be right in the center of these two spindles, so that'll be good. Okay, so now we can render this, and let's take a look. Now before you let it go, turn on the stop sign and tell it to stop before the part load unload. You can also turn on the geometry to see if you positioned everything correctly. If you didn't, it'll show it up here after you render it. So let's click on play. Let's rewind, then play. Okay, subspindle has come forward, and subspindle return. And that's the end of the program there. Now if we zoom this here and look at our geometry, you can see the geometry matches the part there, so we know we put the solid model and everything and put our dimensions in correctly, so this looks good. But you will notice when I rewind it that there shows a part in the subspindle, and of course when we come over there to grab it, you can see that it's going to smash the part that's in the subspindle into the main spindle. But that's okay, because at the very end of this, when we finish off the subspindle, we'll put a part unload, so you won't see that in the beginning. Turn off our dimensions. Okay. Let's go to our subspindle now. Turn off cam. Let's pull up some geometry off this. So let's go to our work groups. Now if you'd like, you could do another work group and just call that turning, and another one for milling. But since the turning really doesn't get in the way over here, we can just leave it in the same work group as the main spindle. But milling, I probably want to choose maybe a new work group. We'll just call this milling sub. Okay, so you can see no geometries there already. Okay, so I'm going to turn on face selection. Select this face. Just right click, and we'll go extract edges. This will not only get the back side here. One thing I forgot to do, notice that's purple. Let's get rid of that. Make sure we're in. Actually, let's get all this out here. Guess I could have done an undo, but that's okay. Make sure you're in the XY plane subspindle. All right, now click on here, right click, extract geometry. Now you'll see everything is blue and yellow, which it should be saying that's in the subspindle. Okay. Same in here. Let's just extract the geometry off here. And I think we have everything because we have the turning. We might want to get the chamfer. Yeah, let's get the chamfer here. Let's extract the edges off that. And I think we have everything we need for the subspindle. Now if you want, you can put the chuck in the body bag to get a little more space on the subspindle. Okay, everything looks good there. Let's check our tools to make sure we have the right tools. Basically we need a spot drill for the sub. So this one over here is main spindle combo spot drill. So we're going to actually put the same type of tool. This is going to be a double holder. So there's going to be one holder that faces the main and the sub. So basically we're just going to highlight this. So if you highlight this, and we're going to start down at 12, I usually leave a couple spaces between here. Double click here, you'll see it basically duplicated that one right here. Now we need to change, of course, a couple of things. It's a combination combo spot deburr. Okay, everything there is the same. The only thing we need to change is tell it it's over here, and we want to make sure it's in position number 5. So this will be 5. And depending on how you have your offsets set, the normal offsets on a DMG is you add 16 to the number on the turret. So this is in turret number 5. So this will be offset 21. This will depend on your machine, so you can decide on your machine what offset you want to use. They should give you plenty of different offsets on there. Cutter comp offset, if you were using that, also should match. Okay, make sure all those match. Okay, everything there looks pretty good there. Now we also need to do some turning on here. I'm going to move this down a couple more spots there. Now we want to do the same thing here with the turning. This is our main spindle turning here. Since I highlighted it, I can just click on this button right here, and you can see it duplicated it. All I want to do now is change it to the subspindle. And this was position number 1, so I want to also change that to 1. And offset, remember add 16, so this will be offset 17. And usually I give it a name like turning sub-spindle. So I know, so post this data when you post the code, so you'll be able to see that there. So maybe let's just start with that for right now, then we'll go on to do the bore. Clear everything out here. And let's go back to top view there, and ZX plane subspindle. Let's make sure we're on the right. Let's go back to the turning there. So there's our turning. Okay, let's do a facing operation. So this will be rough with this tool here. You can see it's tile 12, position 1, offset 17. Front face. Remember we have 210 to face off there. So on this document control, we probably want to move this out a little bit more, because remember we have 210 to face off here. So we don't want to wrap it to 0.25. That's a little bit close. I'm going to say wrap it a ½ inch away from that part. Okay, so this time it'll be ½ inch. And this will be ½ inch. And remember we have 210 thousandths to face off here. And cut depth, we're going to go 60 thou. Don't worry about stock on the finish there. Z, I'm going to leave 5 thou on there. And maximum RPM, that's up to you what you want to go RPM wise. I'll just leave it at 250 surface feet per minute. Maybe we'll bump that up 500, and then 12, 12, and I want a can cycle there. Okay, everything there looks pretty good. Okay, let's click on this face here. Of course, arrow down. Now notice this gives you a warning too in Gibbs. See how this is purple? That's telling you you probably chose the wrong spindle. So open this back up. Yes, we did. So make sure you're on subspindle. Now you can see Once I click on this again, it's back to yellow, which it should be. Drag this above our part. You can always right click and tell it to go where you want it to, but that's okay. We're cutting top down, so we want to cut it. Basically, there's a hole through here already, so we'll just click here. You could put a dimension if you want it to actually go to a certain point. We already did the bore through here, so you probably could bring this up a little bit higher there. Okay, everything looks good there. Click on Do It. Now we have our roughing for that. Okay, the face roughing. Now maybe we want to do it including the flange. So if we want to do that, you could do transverse this way or up and down. Let's just do it right from here instead. And hold the Control Shift down, click on there. And again, a little bit down to here. Let's click on Redo. And now we have our facing off there for the rough. Okay, now while we're at it, we want to do the bore now. Okay, so I'm going to turn my cam off for a moment. And tool number 3, if I click on that, you can see that was the boring bar for the main spindle. Since I have this highlighted, just double click again and it'll duplicate it down here. So this was in position number 3. So this is a double boring bar holder as well. So I'll do position number 3, add 16 to that. That'll be 19. Then I'll go sub-spindle. I'll just do bore sub-spindle. Okay, now that's in the sub-spindle. Turn our cam back on. And this is a roughing, so I'll just change tools there, which is okay. We can leave that in there. Okay, this time it's going to be a front ID. And we already have a bore already through there from the previous tool, 0.687. But we're going to double check that anyway, just to make sure. So this is the rapid 2 and the rapid when it's done. So let's check this. Let's just highlight this, hold the Alt key down and click that button there, and you can see that's 0.750. I probably don't want to rapid right there, so we'll just say 0.6875. And that's where, let's see, the material is, we'll Alt click that again. That should be 0.750. That's where it is. When we're done, 0.687, we're on the right spindle, sub-spindle, 60 thou depth of cut. Just change this to 100 thou depth of cut. I want to leave a little stock on the radius, 10 thou and 5 on the Z, and everything there looks pretty good there. We're on the right plane. So now I'm going to click on the little chamfer there, start off our part a little bit, come down to this chamfer by holding the Control Shift and a little bit on the ID there. Click on Do It. Now something's wrong there with the tool because it's giving me not a very good path, so let's take a look at that. So this is a good indication that you did something wrong, more than likely something wrong with the tool. Let's open up that tool, and we forgot to tell it that it's on the sub-spindle. So you can see now it's on the sub-spindle. So all we need to do is really do a redo. Okay, so let's take and see what we've done so far. Turn on our op sim, let's rewind. Let's make sure we're part load, unload. Let's go up to that point where it stops. Let's slow it down. So there's our facing. There's our bore. So far so good. Now we need to do some finish passes on here. Back to our top view, and we'll just zoom this up here. So I'm still using the same tool, so I'm just going to right click and click Change Process to a contour. Exact same tool, front ID. Everything looks pretty good. We'll change that. That's fine. Okay. Everything there looks good. We'll just leave our dimensions where we have it and click on Do It. So there's our finish pass for the bore. Let's clear this out and let's put another contour in here with our OD. Let's see, we need to of course add the tool. This was our main spindle finish tool. Now we need to make a sub-spindle finish tool, so that's already highlighted. So let's just highlight down here, and this will duplicate the tool. This is going to be the sub-spindle, and this was in turret station number 4, so I'm going to make sure this is on 4, and of course add 16 to that, so that'll be offset 20. So sub-spindle finish OD face. Okay, now I try to keep these kind of in order, so I'm just going to move these around a little bit in the order that we use them, so that looks good. Okay, so let's do a contour with this tool for the sub, and we're doing a OD, and I'm going to wrap it to about 3/4 because that's about, well, we already finished the bore there, so I could come up a little higher. Let's highlight this, hold the Alt key down, click on there, and you can see that's 1.56. I'm going to change that to 1.5, a little bit lower there. And 2.6 should be good. I think I have our clearance at 2.6, which is good, so 2.6 is good there. We're going to come in with a 90-degree line. RPM, let's do 500, and 5,000 is just fine. Just regular flood coolant is good. Make sure coolant's on. There we go, flood coolant. Okay. Click here, come down here, go up, and finish on this face, and up there. We don't need to do the OD there because that was already done previously. Let's do the rendering. We'll turn a few things off here. Rewind from the beginning. I'll kind of go fast till the transfer. Okay, now we're ready to transfer. There's a rough finish, and finish the OD. Now the last few things we need to do is to deburr the holes and this flange here. So let's make sure we're on the right coordinate system. I want to be on the XY plane. I'm going to clear this out here, and we're going to bring up our milling on the sub, and there's everything there that we need. So let's first bring up a drilling process along with our tool. Make sure, again, you're on the right plane, which we are. We'll just zero this out here. Okay, I'm going to stay at 0.1 here, and the surface we want to cut, we'll just Alt-click that, and it should be minus 0.09. Okay, over here, we want to put in the diameter that we want the tool to cut, and these holes are 1/8 of an inch, so I'm going to make this 0.135 there. And how do we want to transfer before we do the next hole and the next hole and the next hole? I'll just go out to 0.1, which is fine. That should be plenty there. Input your RPM and feed rate there, whatever you'd like there. On the rotate, we already are going to deburr one hole. We need to do it 3 more times every 90 degrees. So let's just click, make sure you're on polar and cylindrical. Let's click this one here and click on do it. So that should be the 4 holes around there. Now the next thing we need to do is, of course, deburr the inside there. So we'll just stay there on the same one. This time we'll wrap it in a little bit closer, so I'll Alt-click inside the bore there. That's minus 0.43. I don't want to hit the bottom, so I'm just going to say minus 0.375. We'll Alt-click the bore again. That should be minus 0.43. Again, 0.135. And we want to stay in this hole as we go to the different holes rather than coming clear out to 1/2 inch away, so make sure you have that selected. Of course, input your RPM feed rate. Let's go to the rotate command. We're on the right coordinate system. This time we have 6 holes in there, so we need to do it 5 more times every 60 degrees. And make sure you click on one of the holes there, wherever you'd like to start. Normally I would probably start above the X there, so it's less travel on the Y. So we'll click do it there, and now we should have our 6 holes there. Then the last thing we want to do with the same tool is deburr the outside of this flange. So I'm going to clear this and put a contour in there with that same tool. Again, make sure you're on the correct plane. We'll do polar and cylindrical again. And again, I'll Alt-click this flange here to make sure we're where we need to be. And over here, we'll do it again. Now I only have a 1/8 of an inch to work with from this shoulder there to the tip, so I can't go more than 1/8 of an inch, otherwise we'll be cutting on the straight part of that. So that's minus 0.9, so I'll add to that another minus 0.1. That should be minus 0.19 now. Entry and exit, that's fine there. I'm going to cut in here 20 thousandths and leave a 20 thousandths chamfer on there, so everything there looks good. You could decide where you'd like to start on here. You could start on the flange or the face here. It's totally up to you. I'll just start on one of these corners here. I want to go climb outside, and everything there looks pretty good. We'll click on do it. Okay, let's do the full rendering again, see where we're at. So we'll rewind everything, start from the beginning, and we'll do it fast forward there till we get to the transfer. Now we're at the transfer, so we'll just slow it down a little bit. There's our bore, finish. There's our deburr. You can see polar and cylindrical because the chuck is turning. And then we have our chamfer there. And everything looks pretty good there. We got deburred holes. Nice chamfer on there. Last thing we need to do is, if I rewind this, you'll still see there's a part in the subspindle before it comes and transfers over there, so that's not good. You don't want that to happen and crash into that. So the last thing we want to do, I'll just clear this out and put in a utility, no tool, and we're going to do unload spindle. You can see a drop down menu for unload spindle, parts catcher, subspindle. Now on the DMGs, usually we put in about 8 to 10 inches to 12 inches depending on where the parts catcher sits, but this 8 inches on a DMG works pretty good. You'll have to decide on your machine where you want the subspindle to come up so it drops it in the parts catcher there. So we'll just click on do it. And then as we rewind, you'll see now there's no part in the subspindle. So if we do the whole rendering right from the beginning there, we'll just click play. There's our pole and cylindrical, the holes. And we'll rotate that a little bit. Now, of course, cut the flange. And last pass. I believe last pass. No, one more finish pass. All right, now the subspindle is going to come over after it deburrs. Okay, subspindle's in. Grabbed onto our part, you can see right there, right up to that radius there. Slow it down, click play again. And here we're on the back side now. Roughing that out, finish, or rough the bore, finish the bore, finish the OD. Now we start deburring. And of course the deburr there. And our part is finished. If I click once again, because I have the stop sign to stop at load, unload, so that's why it stopped there. If I click one more time, you'll see the part disappear. But that's the finished part there. Click that, and you'll see it's disappeared. I'll put the chucks and everything in the download section, so you can download those if you'd like. And that's it for this part on the subspindle to finish our second step. Thanks for watching.